Hey, I'm Steven, and today's practice question comes from CramBetter.com, where you can find everything you need to pass physics, taught by yours truly. Let's get into it. Y'all ever feel like conservation of momentum is the most depressing topic? We're always dealing with car crashes and shit. So this 2,000 kilogram car, that's M1, bad things are about to happen to it, is traveling 30 meters per second. Oh, look at that. It collides head on with a 3,000 kilogram car. That'll be my M2, traveling 25 meters per second in the opposite direction. What's the velocity of the entangled cars? Wow, that's graphic. Immediately after the collision. All right, well, let's draw an initial and a final picture for this thing, like we do for all conservation of momentum problems. Very good idea. So M1 is going the plus X direction, so it's looking like this. V1 initial going 30 meters per second in that positive direction. What about M2? M2 is, for very bad reasons probably, heading straight toward it. Not good. V2 initial is equal to 25 meters per second, but be very careful because with momentum, the sign matters a lot and it's up to you to tack on those signs. So it says in the opposite direction, that means it's going to the left and we have to tack on a negative sign there. All right, now we're happy. So what about in the final situation? They become entangled, that means they stick together. So we have a combined mass, M1 plus M2, making this an inelastic collision because they stick together afterward. And we don't know the VF. We don't even really know what direction it's going to go afterward, but we're about to find out with the math. That math, of course, is conservation of momentum. Total P initial equals total P final. That's how we solve an inelastic collision. Okay, so in the initial state, we got two objects. We got to write down the momentum for both of them. That's going to be M1, V1 initial, plus M2, V2 initial. We didn't have to break anything into components, do X and Y axes, because everything's in the X axis here. This is a one-dimensional problem. On the right-hand side, we have just one object, which is the combined mass of both cars together. They're going to move at the same velocity, VF. That's what we're trying to solve for. So we're just going to rearrange this, get VF by itself. So VF is going to be equal to, rearranging algebraically, it's M1, V1 initial plus M2, V2 initial, all divided by the combined mass, M1 plus M2. If we plug that carefully into our calculator, we should get negative 3 meters per second. Being careful with our signs allowed us to discover that the final velocity was negative in the X direction, which means we can go back to our picture if we want to, and we can say with confidence now that this little mess is heading in that direction. So the velocity is in fact in the minus X direction. If you want to pass your math and science classes the easy way, head to CramBetter.com. We've got study guides, practice exam questions, and shorter, easier explanations of every topic in your class. Click the link in the video description, and I'll see you there.